Nana's Beauty Science Salon, Day 4. A. The Jewelry Reactivity Room. The next door in Nana's salon had a gold handle. The sign said, "The Jewelry Reactivity Room." Nana opened it. Inside there were rings, bracelets, earrings, metal tools, a silver mirror, and a tiny safety flame behind glass. Tino said, "This room looks expensive." Nana said, "It teaches why some metals are used for jewelry and others are not." Debbie picked up a gold ring. She said, "This one does not rust or change color easily." Nana said, "Exactly. Gold is very unreactive." Tino said, "So that is why gold can be found pure in nature." Nana nodded. "Yes, gold and silver do not react easily, so they can sometimes be found as elements." Then Nana picked up a strip of magnesium. She placed it safely behind the glass and lit it. The magnesium burned with a bright white flame. Tinos jumped back. Nana said, "Magnesium is much more reactive than gold. Reactive metals combine easily with other substances." She wrote on the mirror, "More reactive metals form compounds more easily. Less reactive metals can stay pure more easily." Tino said, "So reactivity means how easily a metal reacts." Nana said, "Correct." Then she showed him a tall chart. At the top were very reactive metals. At the bottom were less reactive metals. Nana said, "This is the reactivity series. It ranks metals by how easily they react." Tino said, "So the higher the metal, the more reactive it is?" Nana said, "Yes. And the more reactive a metal is, the harder it is to extract from its compound." Debbie said, "Why?" Nana said, "Because reactive metals hold on strongly inside compounds. More energy is needed to separate them." Then Nana placed 3 small dishes on the table. One had magnesium, one had zinc, one had copper. She added acid carefully. The magnesium fizzed quickly. The zinc fizzed slowly. The copper did not react. Tino said, "Magnesium is the most reactive. Zinc is less reactive. Copper is not reacting." Nana said, "Good observation. The speed and strength of a reaction help compare reactivity." She pointed to the bubbles. Nana said, "When a reactive metal reacts with acid, hydrogen gas is produced." She wrote, "Metal plus acid makes salt and hydrogen." Tino said, "The bubbles are hydrogen gas." Nana said, "Yes, and the hydrogen test is a lit splint." Tino smiled. "A squeaky pop." Nana said, "Correct." Then Nana showed a small bottle of water. She said, "Some metals react with cold water." She dropped a safe demonstration metal into water on the screen. Bubbles appeared. Nana said, "Metal plus water makes metal hydroxide and hydrogen." Tinos repeated it. "Metal plus water makes metal hydroxide and hydrogen." Then the screen changed to steam. Nana said, "With steam, the product is different." She wrote, "Metal plus steam makes metal oxide and hydrogen." Tino said, "Water makes hydroxide. Steam makes oxide." Nana said, "Exactly. Steam is hotter and has more energy." Then Nana showed a piece of metal reacting with oxygen. She said, "Metals can also react with oxygen." She wrote, "Metal plus oxygen makes metal oxide." Tino said, "That is oxidation?" Nana said, "Yes. Oxidation happens when a substance combines with oxygen." Debbie pointed to the gold ring again. She said, "So gold is used for jewelry because it does not react easily." Nana said, "Exactly. But magnesium is useful for bright flares because it reacts strongly." Tinos looked at the mirror and read the room script. The reactivity series ranks metals by how easily they react. More reactive metals form compounds easily. Reactive metals are harder to extract. Gold and silver are unreactive, so they can be found as elements. Reaction speed and bubbling help compare reactivity. Metal plus acid makes salt and hydrogen. Hydrogen gives a squeaky pop. Metal plus water makes metal hydroxide and hydrogen. Metal plus steam makes metal oxide and hydrogen. Metal plus oxygen makes metal oxide. Oxidation means combining with oxygen. Tino said, "So jewelry is chemistry." Nana said, "Everything is chemistry. Tomorrow we use the reactivity series to predict displacement reactions."